This video will show a really cool way to create leaves in Houdini. And the main two things we're going to do are we're going to use the trace node, and then we'll also use a texture pack that we can download from Fab. Right, so this is one such texture pack. This has some different kinds of leaves. And if you go through, there's a free section. If you go to Vegetation, and then I think you have to plug in price is free. There's quite a number of different leaves in here that you can get. Right, so here's another one that's a birch leaf. And the cool thing is you get different leaves. So you're getting some variation that's based on actual photography. And when you download this, you'll get an opacity map. And the trace node can use this as black and white values in order to generate an outline of the leaves. All right, so if I go to wireframe, you can see that we have a bunch of points on a line that are making up the perimeter. And then there's actually a single polygon in the center. All right, so really cool stuff. It gives you like this nice organic edge, which I think is a cool thing to have in a leaf. And this is a little better than trying to model it by hand because this is very fast. So after this, what you want to do is throw down a remesh node. And that's going to give you this remeshed leaf topology. And you can dial in the settings of both of these. If you want to be more optimized, you can reduce your remesh polygon density. And then these come in backwards. So I'm just throwing down a reverse. And then if you want UVs, you can just do a UV project. And right off the bat, you'll get the same exact UVs that your maps have. Right? So this is the color map. And since we generated this from the same map UV set, right off the bat, when we do a UV project, we get the same UV coordinates. So after that, you can throw down a quick material, and that'll get you your color. And then what I like to do is prep this a little bit. And depending on how you want to use this kit, you can prep it in different ways. But one nice thing to do is to throw down a for each loop. And if I go to the end of this, what I'm doing is I'm creating the path attribute. And if I select by alembic paths here, there's this kind of outliner window, which is similar to Maya. And you can see that we now have a path name for each leaf. And that was based on the connectivity of the geometry. So if we export this to Maya, now because we've done this, it's going to show up correctly in the outliner. Or you can use this to instance in Houdini or in Unreal. The way that the path attribute works, if you're not familiar with this is an attribute create node. And I'm using the iteration to create a number for each of these. Right? So this will process each connected leaf individually. And it's assigning a number based on the iteration. Right? So the iteration is a detail attribute. And if you want to access this, what you have to do is select this for each begin one, and then hit this create meta import node. And what that does is it creates this thing, and I can throw down a new one. So if you do for each connected piece, that gets you this template of nodes. And then you have to select this one and do create meta import node. And what I like to do is I've edited this as a permanent default, and I've added a float here. So if you go to edit parameter interface, you can add a float or an integer, right? So the iteration is an integer. And there's a very simple expression that you can put in here, right? Which is detail. And then we're grabbing the node name. You can also just type in a dot. And then the attribute name is iteration. Right? And then we can go through and process this and automatically create our naming for each leaf, which is pretty cool. The way you would do this in Maya is just to go in and name them. But in Houdini, we can do this procedurally using a for each loop. Another nice prep thing that we can do is to move all of these things to origin. Right now they're laid out in a kit, but if we turn on our grid, here's the origin at 0. And there's a very simple way to move each of these. If you search for labs axis align, this is a really handy node that can move things to the origin. And you'll need to have labs installed. All right, so if you don't see this in your tab menu, what you can do is go to the labs shelf, and then you need to install labs. So once we have a match size, if I just drop this in here, you can see automatically we get all of these to origin. And we're just adding this as an operation to the for each loop, which is really cool. So in addition to naming these automatically, we're also moving them to origin automatically. And for instancing, we would actually want these leaves to be positioned up in Y. And you can do that, right? So in justify Y, instead of center, we can go mid. And then the minimum point of each leaf is going to be centered on the origin. And we can also offset this, right? So if we go down just a bit, and that way we don't have any floating leaves when we go to instance. And to demonstrate instancing really quickly, I made a quick twig in ZBrush, and I brought that into Houdini. And now we can start instancing our leaves. Right, so in order to do that, we need some points. Right, so we can scatter. There's a newer node called scatter and align, which is really useful. So I'll just go ahead and use that. So I now have some different points that have been scattered on this surface here. Right, so we actually have 12 points. We can have more or less. And then in order to copy our leaves to the points, we can use copy to points. And there we go. And obviously the scale is too small, and we're getting all of the leaves instead of a single leaf. In order to set our scale, there's a couple things we can do. We can transform our leaves, right? So we can make these a little bigger. So I've merged in our twig for reference, right? So maybe we'll use a base of 15. And if we want to randomize our scale, we can do that as well. All right, so if you do an attribute randomize, and you want to put this on the points, and instead of color, we want to do p-scale. And this is going to randomize between 0 and 1. And we can actually disable this transform node now, or we can reduce down the size of this. And then with the attribute randomize, we don't want any leaves that have a scale of 0. So we would do something like 0.5 to 1. And then we'll get a different scale for each leaf. And then in order to have only a single leaf from our kit, we can use something called this piece attribute, which by default has a value called name. So we need to assign that to our points, and then also assign it to each leaf. And if you hover over this, there is some explanation of what this is. But essentially the thing to know is that this is an integer, right? So an integer is a whole value, like 0, 1, 2, 3. And we're going to assign this to each leaf, and then use that to randomize which leaf is instanced onto each point. And we can assign this name attribute very easily up here in our for each loop. And to do that, you can throw down an attribute create. And we want this to be an integer. This can be a point or a primitive. I'll just leave it for point for now. We want the type to be an integer. And a good way to view this is using the geometry spreadsheet. So if I look through the attribute create inside the for each loop, we're seeing the last piece, right? So this is piece 22. And if we go into geometry spreadsheet, we can now see there's something called attribute 1, and it has a value of 0. Right? So instead of attribute 1, we want to call this name. And we want to consecutively increase this value from 0 to however many leaves we have. And again, we can easily do this using this iteration. So very conveniently, I have this plugged into a custom integer here. And again, I created that using the edit parameter interface. So if I copy this parameter, I can now paste it into the value of this name using paste relative reference. So we now get this value of 22 because this is the 22nd iteration. So this name is now 22 for this leaf. And if we look through the end here, showing all of our leaves, we'll see that they get a value from 0 to 22. And another way to visualize this is if you go to select, and then if you select by attribute, and we want to go to point, And if you go to attributes, you can go to name. And now you can select. Right, so there's 0, there's 1, there's 10, 16. Right, so each of these leaves has this name attribute on the points. And in order to use that in our instancer, we also have to add the attributes onto these points. And we can use that attribute randomize node again. And the attribute name is name. And we want the max value to be, in this case, 22, because that's how many leaves we have. So if you have a different number of leaves, you would want to set this to be the max number. And if we go to our geometry spreadsheet again, if we go to points, but if we find our name attribute, which is here, you can see that we actually have these decimal places. And that's because we need to change this to an integer, right? And we can see that there's no way to change this from a float to an integer within the attribute randomize. But what you can do is throw down an attribute create before the randomize and just type in name. And it's a point attribute, and we'll just make it an integer. And that's going to carry through to the randomize. And we can see now that our name value goes from 1 to 21. And we're actually looking for 0 to 22. And the reason we don't have 0 or 22, we're also missing some other numbers in here like 2 and 3. And that's because we don't have that many points. Right, so we only have 19 points. But if we increase this enough, right, we'll eventually get a name attribute that contains all of the leaves. But that's not too important because if you only have a small number of leaves, you don't necessarily need to use every single leaf in your kit. So now if we look through our copied points, we now have a single unique individual leaf copied to each point, which is really cool. We have this blue display because this is a single-sided object. If you want to turn that off, you can hit D or hit the display options. And there's this, under markers, there's this tint back faces. And again, that's the name attribute. And in order for this to work, you do have to check this box. Right? So in copy to points, we're using piece attribute and it's set to name. So really cool stuff. We now have a functioning instancer that is instancing unique members of a kit bash. Another upgrade we can do is instead of having these perfectly flat leaves, we would want to add some shape that's a little more realistic. One way to do that is to bend the leaves, right? And they can bend around the stem, and they can also bend lengthwise, and they could also twist. And these are things that you could do in ZBrush, but we can also do them in Houdini. And the nice thing in Houdini is that we can randomize these bend features. So we'll do that next. And one way to do this is to add the bend to our for each. So if we make some space, we could put this after our match size. And we can visualize one leaf here. And we can throw down a bend node. And I like to always make these blue. And a really helpful thing is to hit this universal handle or manipulator. And if you right click here, you want to show the capture. And that's going to give you a good sort of visual information about where this thing is located. And currently you can see this gizmo here. So it's shooting out to screen right here. And there's this handle. So what we need to do is align this so that we're capturing up. And we want the captured length to match the size of the leaf. And there's a couple of simple expressions that we can do for that. So first we want to set our capture direction to up in Y. Right, so now it's oriented. And then we also want our capture length to be correct, right? So this red icon is a controller for the capture length. And you can set this manually, but that's not going to work for us because we want it to automatically calculate each leaf, and each leaf is a different size. So there's an expression we can put in, and I always keep a little text file for this kind of stuff. All right, so these are useful snippets of code. And there's this B box, and then it's D_size. And that'll give us the size of the bounding box, right? So essentially the size of the leaf. And if we put that expression into the capture length, I have it as Z size, but we actually want Y in this case. And that will automatically set our capture length there, which I think is really cool. And now if we use this, you can see that our leaf is bending. And that's going to give our bend along this axis. But I think we probably want to go the other way. And you can use this, this is that capture option up here. And you can use this to rotate. Right, and that is essentially changing some of these parameters inside here. Right, so if we rotate it here, we can now bend this way. It's really, really cool. There's also a twist feature. So if you select this, you can twist, and now we get this other control. So that'll twist our leaves. So if we want to preview this, we can go back here and look at the result of our kit. And if we toggle off this match size, we can see what this is doing. But that's actually gonna mess up our bend because we need this to be at origin in order for the bend to work. So to visualize this, we could use an exploded view. So if we look through here and then just scale this up, there we go. So we now have our bent leaves. And the problem we're seeing with this is that it's all the same bend. So we're going to want to randomize the angle of this and how much it's bending. And we can do that in the for each loop. So if we go back to our bend node, I'm going to toggle off twist for the moment. So we'll just look at this bend angle. And we want to randomize this between I would say a very small number and a large number. Right? So something between, this is -262, but I would say maybe -180, 120, let's say. So we could do -120, and if you want it to go positive as well, so we could go from -120 to 120. And there's a pretty easy way to do that. Right, so we can grab a random number from our metadata node. And this is another custom parameter that I've added. Right, so if you go to edit parameter interface, this random number is a float. Right, so we can find where it says float here and then just drag a float over. And the expression for this is rand. So rand will give you a random number. And in parentheses, we're referencing this iteration. So what it's doing is it's giving a random number that changes for every iteration. And you can see the random number for iteration 22 is 0.490953. And this is what we can use to randomize our bend. So if I copy this parameter, and we can now paste that into here. So paste relative reference. So that's going to give our bend a matching value to that random number. And it's going to be really hard to see because this is very, very small. But if we multiply it, say, by 100, we now have a bend in the leaf. And you can see that there is some difference here. Right, so you can see this leaf has a very slight bend, and then these have more. So this is working, but there's a better way to control this, and that's using the fit expression. So in order to fit this, what we want to do is fit it, as we said earlier, from -120 to 120. So if you type in fit and then parentheses, it'll give you this this handy sort of explanation of what this is. So it returns a number between a new min and new max, and it's relative to a number in the range between old min and old max. So essentially you can do fit and then a number, and then you have old min, old max, and then new min, new max. So essentially what we're doing is our num is the random parameter up here. So this random number is our num. Go back here. So this num is that random number. And then old min is can be 0. Old max can be 1. And then new min is -120. And new max is 120. So let's go ahead and type that in. So I've got the num in here. And then we need a comma. And it gives you the nice key again. So old min is 0. Old max is 1. New min would be -120. And then new max will be 120. And then you do closing bracket and enter. And just like magic, we get our leaves that now have randomized bend. It's really cool. And again, we're looking through this exploded view just to see them in space. But if we look back through our instancer, we can see that this is now working. So right off the bat, we're improving our realism quite a bit. And we can continue to improve this by bending along a different axis, right? Or twisting. Right? So if we go back to our bend node, we can enable twist. And this is the same twist for everything, but we can do a similar expression here, right? So if I just copy this, we can now twist between a min and max number. So that's -120 to 120. So same as our bend. So that's pretty darn good. You can play with this more. You can make it more or less, but I think that's working pretty well. Another bend that we can do is one that happens along the stem. So let's take a look at that. And if we go back to our match size, we can look at one leaf at origin. And I'm going to throw down another bend node. And again, I like to make these blue. And for this one, we'll go to our handle and then make sure our capture is active. And we want to align this a little bit differently. Right? So we want this to be aligned this way. And we're actually trying to bend like this. Right? So we want to bend this leaf almost like a curl, right? So it's bending along this this axis. And there's a handy checkbox. You can deform in both directions. Right? So if you want it to be bent on both sides of the leaf, you can do that. And again, we're going to want to calculate this. Right? So our capture length here should match the bounding box. And we can use our expression again, which is bbox and then size. And in this case, we want the x-axis, right? So bbox, d_x size. And this is actually, it's calculating the width or the size along x, and then it's putting that into this length of the capture. And we actually want to divide that by 2 in this case. All right, so that should work. Another expression you can use for this is this min and max of the bounding box. All right, so we would just copy this, and we would want our x max like that, which is about the same. So now we have our curled leaf, which is really cool. And again, we want to randomize this between a min and max, and we can just copy our expression again. And in this case, it returned a value of -2. If you click here, it'll toggle the expression versus the output. All right, so we're getting -2. But if we go back to our exploded view here, we should be able to see, yeah, that there's a range of this curling bend that we get from -120 to 120. And then if we toggle on our other bend, so we've now combined these 2 different bend nodes, which is pretty neat. And we can see the results down here. It's pretty cool. There's our bent leaves. One last thing we can look at is going back to the scatter line. And it's a pretty cool node because it automatically gives you some more randomization options. So if you go down here to alignment, there's this max random cone angle. So if you slide this around, you'll see that this is randomizing the direction, which is really cool. And then you can also rotate around the normal. So there's a min and max. And this is going to twist the leaves around their axis. And in reality, you would want to look at reference, and I think that there's a logic to the way that the leaves are rotated so that they can capture light. But this gives you a lot of tools to do that, which is really, really neat. There's also a seed in here, so you can change the seed around and get different looks. We can also play with how many points we get. We can play with our scale again, right? So we can say, maybe we want some larger leaves. This doesn't account for penetration like this, so that would be some additional upgrade to do. One way to fix that is with vellum. You can untangle your leaves. Or you can just find a seed where it's not noticeable. And then there's also relax iterations. So if you reduce this down, it will not try to separate out the points. What relax does is if 2 points are too close to one another, they will spread apart. So if we go back to having some larger leaves, if you're seeing a lot of intersections, you can relax these more. And that can solve that issue sometimes because it'll move the leaves apart from one another. So that's relax iterations. So one more thing we can do is if we look at these, they are pretty smooth. And in Houdini, there's a lot of really cool ways to sort of mess up your geometry. And what we can do here is we can add noise. And a really good node for that is the mountain SOP. And what I would do is you could do this before or after the bend. But if we just look through the bend node here, and if we put down our mountain, you can see that it's moving our points around. So this adds a lot of nice, just kind of warble to our surface. And you can change, the element size, and that's going to change the frequency of the noise. And there's also the amplitude. So if we look through our final results, so that's with the mountain SOP. So that'll add some nice realism there. And if you wanted to, you could randomize this in the same way that we randomized our bend. We notice that this is the base of the stem. And if we don't want to have leaves here, there's a couple things we can do. One thing you can do is if you throw down a delete, you can delete points, and instead of by number, you can do by bounding box here. So you can delete points that are near the stem. Right? If you click the handle, you can move this box around. Like so. So that'll delete any points that are within that bounding box. You can also use a sphere. Right, so that's one way to do that. Another way is if it's too difficult to create the bounding boxes, what you can do is we can paint a mask that tells the scatter line where to put the points or where not to put them. And one way to do that is with paint a mask. So this lets you paint an attribute, right, which we can call density. By default, it's called mask. That's totally fine as well. And it is a value of 0 where it's blue, and then it's red where it's 1. So what you would want to do is you can either paint it or you can flood it to 1. So if you go to fill, you can just click and it'll fill. And if you right click and then go back to volume, you can, if you hold down control, you'll get the background float of 0. And you can paint that in there. And you can also smooth it out, right? So if you hold down shift, smooth it, which is pretty cool. And then if we look through our scatter line, we're still getting points in this area. So what you have to do is check this density attribute. And that should be set to mask. Right, so that's now killing off any points that would be at the base. So now when we look through here, we now no longer have any leaves at the base. We can also paint a mask that defines the scale of the leaves. So let's say we want the smaller leaves to be at the end and larger leaves to be towards the base of the twig. We can throw down another paint a mask node. And this one we can call, under attributes, we can call it leaf size. And it defaults to a value of 0. So what we want to do is paint in, some small value here, right? So we could do 0.2. And if we go to our handle, we get the brush and we can fill. And if I hold down control, we'll get this 0.2 value. If I click, we get a value of 1, right? So 1 is red. This kind of bluish teal is 0.2. And then we can start painting in a value of 1. Right, so value of 1 will be here. And then maybe, 0.5 or 6 can be over here. And then we can also smooth. Right, so hold down shift and just kind of smooth like so. So we get this kind of gradient that goes from the root to tip. If you had a lot of twigs, you would want to do this in a way that's more procedural. But this is essentially what you would want to end up with. Is a value that goes from 1 to something low, like 0.2. We can use this map to affect p-scale by looking at our points. And then one way to do this is simply to rename it. Right? So if we do an attribute rename, and we want to rename from leaf size to p-scale. And it's giving an error message because it says p-scale already exists, but you can just check this overwrite. And if we look at our result now, it's really cool. So we have big leaves to small. And we can also randomize this, right? So I've disabled the randomize, but if we enable that again, what it's going to do is it's going to override our gradients that we just did. But to fix that, we can change the operation from set value to something like multiply. Right, so that's going to respect the initial data, and it's going to multiply this by our min and max value. Right, so you'll get some variation within that large to small leaf range. And we can, play with these values, right? So it could be 1 to 2.2. And that's about it. There's lots more cool stuff you can do with this, but this is a general overview of how we can easily create leaves in Houdini using a map like this from Fab, which is free and just easy to download. And we instanced by creating a kit bash and then randomizing each leaf and then copying these onto points. So it's a really powerful setup, and I hope you enjoyed this video.